Hi everyone. So according to my students, I've been sounding a little like a zombie on my video, so I'm going to try to be a little more peppy, maybe sound a little less like I'm talking to my computer and a little bit more like I'm talking to you. So in this video, we're going to be using the ratio method of cross multiplying, where we have our x, well, let's say, are given in a single problem. Um, set to an X amount of whatever unit you have over that unit over here, as well as the unit for your given, and we cross multiply to solve for X. If you are not familiar with this method, you'll get familiar through this video, but you can also go back and watch some of my videos from the mole unit, which is playlist number 6, as well as the first video for this playlist. Now, in problem number 1, it says in the following reaction, and we can tell that this is balanced. We already have some coefficients here. How many moles of oxygen would be required to react with 16 moles of hydrogen? Now, it's important to note that oxygen is by itself, and anytime oxygen gas is by itself, it's going to be diatomic. Okay, and we can see that here because there's a 2 subscript. And the same can be said for hydrogen. There are 7 diatomic elements. I remember them by saying Hofbrinkel. Um, Hofbrinkel, yes. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are our 7 diatomic elements. So when we are writing this, we're going to first identify what is given to us in the problem. And they tell us that we have 16 moles of hydrogen. So we're going to take our 16 moles of hydrogen and write that down first. Okay, and we're next going to identify what they're looking for. Okay, in this case, they are looking for how many moles of oxygen there are. So that is what we are trying to identify. So we're going to set it equal to X moles of oxygen. Now, just like in a treasure map, X marks the spot, and we are trying to solve for X algebraically. Now, in order for this to work, we set it into a fraction or a ratio, and whatever unit is on the top, we bring to the bottom. So if I have moles of hydrogen on the top, I'm going to have moles of hydrogen on the bottom. Let's pause this video so I can plug up my computer. And we're back after that mild interruption of my battery. So to recap, if we have moles of hydrogen on the top, we're going to bring moles of hydrogen to the bottom. And same on the other side. If I have moles of oxygen on the top, I'm going to bring down the unit and element, moles of oxygen, to the bottom. Now, remember, we've always talked about how we always write 1 beside mole. Okay, and we're going to multiply in order to keep our ratio the same by the mole ratio from our balanced chemical equation. If I look at hydrogen, I see a 2 here in front of hydrogen. That tells me that I have 2 moles of H2 for every 1 mole of oxygen. That's my mole ratio that I'm looking for. So I multiply my hydrogen by 2 and I multiply my oxygen by 1. Now when we reduce this or simplify this, we're going to have 16 moles of hydrogen over 2 moles of hydrogen. And we're going to set that equal to X moles of oxygen over 1 mole of oxygen. Now in order to solve for X, we are going to multiply across and then divide. So what this will look like is we will first in our calculator say 16 times 1, which we know will be 16, divided by 2 will give us 8. These units cancel out, and I will just have 8 moles of O2 is equal to X moles of O2. So I've successfully solved for X, what I was looking for. Now let's try a different problem where it's a little bit more steps. If we look at problem number 3, says in the following reaction, AgCl plus sodium nitrate produces silver nitrate and sodium chloride. How many moles of silver chloride are needed to react with 4.0 grams of NaNO3? So again, we're going to decide how many, or like what's given to us first. So what's given to us is we have 4.0 grams of sodium nitrate, and they ask for how many moles of silver chloride they are looking for. So what we're going to do is we are going to again write down what's given to us, our 4.0 grams of NaNO3 or sodium nitrate, and we're going to set it equal to our what we're trying to find. So X moles of silver chloride. Now, with this method, again, we are going to set it into fractions. Whatever unit is on the top, I bring down to the bottom. So I will rewrite grams of sodium nitrate, and then on this side, I'll rewrite moles of silver chloride. Now, we just spoke in problem number 1 about how we always write the number 1 by moles, but over on the left side of my equation, or my mathematical expression, I have grams. Now, what gets written by grams? Well, that would be our molar mass, which I calculated a couple of molar masses and wrote the answers over on the right side of the problem. And we notice that the one we're looking for is going to be this one right here. Okay, now the units for molar mass are always grams per mole, and that's because if you look at the way our problem is set up, you'll always have grams equal to 1 mole. That's built in to the way we're writing our mathematical expression. So I'm going to write my 85.00 grams right there. Now, because we are looking at two different um, problems, two different compounds. We have sodium nitrate on the left and silver chloride on the right. We still have to multiply by our mole ratio in order to keep things balanced. Now, if we look at sodium nitrate, there's nothing in front, and if I look at silver chloride, there's nothing in front, which means there are ones. Now, if I multiply by 1, that doesn't change anything mathematically in my problem. So I'm just going to cross multiply here. 1 times 4.0 is 4.0 divided by 85. So when I do this in my calculator, and we say 4.0 divided by 85, we will get 0.047 moles of silver chloride is equal to X moles of silver chloride, which is exactly what I wanted. Now, if we go on to look at problem number 5, is a little different in the fact that it's not only is it asking for, giving me grams of a compound, but it's also asking me to find grams of a different problem. In this case, it's asking for grams of water. So we're going to repeat the same steps that we've been following by writing down what's given to us. So we are given 52 grams of C3H8, and we set it equal to X grams of water, which is H2O. We put it over a fraction. Whatever is on the top, we bring down to the bottom. So if I have grams of C3H8 on the top, I'm going to write grams of C3H8 on the bottom. and same with grams of water on the other side. Now we spoke about how anything that gets written by grams is always, always, always going to be your molar mass. Okay, so I calculated the molar mass of water in C3H8 before we started the video, so we didn't have to waste time. If you're not sure how to calculate molar mass, go back to playlist number 6, watch the video molar mass, okay, and you can figure out how we got these values. But the molar mass for C3H8 is 44.11 grams, and the molar mass of water is 18.02 grams. And now, again, because we're going from one compound, C3H8, into another compound, we're converting, kind of like if I was converting from dollars to pounds, or dollars to pesos, or dollars to rubles, we would use a conversion factor. We're doing the same thing. And in this case, our conversion factor comes from the moles in our balanced equation, which there's only 1 mole for C3H8, but there are 4 moles for water. So when I simplify this problem, I'll have 52 grams of C3H8 on the top divided by 44.11 grams of C3H8, and I set it equal to X grams of H2O divided by 4 times 18.02. So when I do that in my calculator, I get 72.08 grams of H2O. And all that's left to do is cross multiply. So when I cross multiply, I'm going to multiply 72.08 times 52, and then divide that number by 44.11, and I will get 84.97 grams of H2O equal to X grams of H2O. Now, this video should be very helpful for you for your quiz if you are in second period and taking it in the morning, but also it is helpful because you have a quiz this week. So please, please, please study, watch, come ask questions. Remember, tutoring is Tuesdays and Thursdays after school.